Bismillah ar-Rahman ar-Rahim. So let's continue in chapter 5. Very lengthy chapter. So we stopped last time. We calculated the contact force in this situation when the force is applied from left to right. Now let's do the same case if the force is applied from right to left. So we have 5 kilogram and we have 10 kilogram, and the force now is applied from right to left. And we are interested to calculate the contact force. Previously, we calculated the contact force as 5 Newton. Now we apply the same method. We know that acceleration is equal 1 meter per second square. So we apply Newton's law on this mass. F net must equal 10 kilogram multiplied by 1. So it is 10 Newton. It is 10 Newton. So that means that this mass received 10 Newton, and then it has to return 10 Newton. So the contact force in this situation تساوي 5 نيوتن 10 نيوتن.
Doctor, can you repeat the previous example so we can
No,
link them
no,
together?
no, Sheikh, we don't have any time to repeat.
No, this one, the upper one.
This one ولا the previous one?
Yeah, that one. The previous one.
The previous one, it's recorded.
Okay.
يعني our time يا جماعة الخير يعني the time allocated for chapter 5 is 2 lectures only. Now this is the third one. So if you have any question regarding the previous lecture, just watch the video.
Okay.
So we realize that if it is from left to right, contact force 5 Newton. If it is right to left, the contact force is 10 Newton. And this is interesting because same situation, same masses, same objects. If you apply the force from right to left, it will be different than if you apply the force from left to right. And I'm talking about the contact force, the contact force. Of course, if you have 3 objects, also it will be the same. Just you apply the same exact method. So I will just go through it very fast. So now I have 3 objects, 5 kilogram and 10 kilogram and 15 kilogram. And this is my force. Let's say F is equal 30 Newton. So we need to calculate the contact force at point A and the contact force at point B. So we find the acceleration for all the objects. F is equal ma, and that is 30 kilograms of the acceleration. So the acceleration is equal 30 kilogram over 30 Newton. Oh, sorry, 30 Newton over 30 kilogram اللي هو 1 meter per second square. So we find the acceleration, we apply Newton's second law for the 10 kilogram. So what is F is equal? M A, now I have to use M2, M1, M2, M3. And that is 10 kilogram multiplied by the total acceleration, that is 10 Newton. 10 Newton. That means it will receive from M1 some force, and it will receive from M3 some force, and the net force, so this is net, the net force will be 10 Newton. The net force will be 10 Newton. So we solve for point B. F net is equal M3 multiplied by A, and that is 5 kilogram multiplied by 1 meter per second square, so that is 5 Newton. So we know now that M3 must receive 5 Newton. So it will give 5 Newton. It will give 5 Newton. So we know now in M2 that from the 5 kilogram it will receive 5 Newton, and it will give 5 Newton to the M3. Now what's left is M1. That is 15 multiplied by 1. That is 15 Newton. So that means finally that M1 receives from the left 30 Newton, so we must receive from the right 15 Newton. So this is, so that means it will give 15 Newton. And now everything is working out. For M1, it receives 30 from the left and receive 15 from the right. So that is net force is 15 to the left. For the second mass, it received 15 from the left and 5 from the right. So net force is 10 Newton. And for the last mass, it received 5 Newton from the left and gave 5 Newton to the left. So it is working. So that's the 3 masses. So as you can see, it's just applying the same method, and we get the contact force. So the contact force B is 5 Newton, and the contact force A is 15 Newton. So that means at A, contact force تساوي 15 نيوتن، وat B, contact force is equal 5 Newton. And it will give you different results if you apply the force from right to left. طيب. Now let's have this example. تفضل.
For A, it should be 10, right? 10 Newton.
No. For A, it should be 15 because the acceleration of M1 is 1 meter per second square. That means the net force applied on M1 is 15 Newton. Since it's receiving 30 Newton from the left, that means it has to receive 15 Newton from the right, and that's the contact force. That is the contact force. Yeah, the box M2, from the left, contact force is 15, and from the right, contact force is 5. M2 will give to the left 15 Newton, and it will give to the right 5 Newton. So the net for M2 is 10 Newton. It will receive from left 15, and it will give to the right 5. So net is 10 Newton. M1 and M2 is 15 Newton, that's correct. M2 and M3 is 5. And that's because the force is from left to right. If you apply the force from right to left, it will be different. طيب. Now another typical problem, and you will see it in all physics books, is the situation when you have an object moving up or moving down, and talking about its mass, its weight, sorry, talking about its weight. Like in this situation, suppose that a person standing on a balance, and the elevator is going up with acceleration or going down with acceleration, net acceleration. Gravity is always there. So what will be the weight for the person in this situation, and what will be the weight of the person in the other situation? This is a typical problem. You will find it in all physics books. So let's try to explain it. So here is our situation, the first one. So we have tension up, and we have gravitational force pointing down. So now the object is moving up with acceleration. Moving up with acceleration. Now it's always confusing for the students. Should I write mg minus t or t minus mg in this equation? Well, if it is moving up, it's clearly that tension is larger than the force of gravity. Because it's larger, we write T minus mg is equal ma. So that means tension is equal mg plus ma, or g plus a. So if the object is accelerated upward, the apparent weight on the scale will be larger, or the tension in the rope will be larger. And that's, of course, we feel it when the elevator is going up. طيب, the second situation, well, the second situation, I will just change the color. So here is tension, and here is mg. And it is moving down with acceleration. In that situation, which is more, mg or tension? Well, it's clear because it's moving downward with acceleration. that mg is larger than t, so I write it mg minus t is equal ma. يعني tension is mg minus a. So if the object in an elevator and it is accelerating downward with a net acceleration, the tension will be less. The tension will be less. Or the weight of the object on a balance, it will be less. It will show less. And again, this is typical. You will find it in all physics books, this situation. That you have an object and the object is accelerated up or accelerated down. If, of course, if it is not accelerated, it's just moving with acceleration is equal 0, we end up with a situation t is equal mg, which is normal. Which is normal. Any question about this situation? Well, we just apply, students ask, how did we get? Well, we just apply summation of forces is equal ma. Net force is equal ma. So what is the net force? We have acceleration from up, we have acceleration up, and gravitational force down. So that means net forces, tension minus mg. A situation, if acceleration is equal 0, خلاص, we end up with a situation that tension is equal mg. Okay, so now we move to this typical situation. What is a typical situation? It's called Atwood machine. We have a massless pulley, massless rope, and we have two masses. So how to solve this problem? So we have a pulley and two masses. Let's call this capital M and the other one small m. So how to solve it? Well, it is depending first on the motion. Is it moving up or moving down? So if you know both masses, of course, if capital M is larger, it will move in this direction, if you know the masses. So M will move that in this direction, and small m will move on the other direction. If it is the reverse, it is the reverse, no problem. So let's write the equations. So for capital M, it is going downward, so that means mg minus t is equal capital Ma. That is equation 1. For the small m, it is going up, so that means tension is larger than small mg, and it's equal Ma. That is equation 2. So now we have two equations, we can solve the problem. تفضل يا خالد.
دكتور معلش، بس الام اي مش اساسا لو او ليش بتساوي ام اي؟ مش المفروض لو بتساوي الام اي معناها انه جسم ثابت؟
لما نحكي ام اي يعني في اكسلريشن، معناته الجسم غير ثابت، في حركه with acceleration. يعني حتى لو كانت الحركه without acceleration, this does not apply. The whole thing we are repeating again and again and again. We are applying Newton's second law. F net is equal ma. So there is motion with acceleration.
طب لو الجسم كان ثابت بتصير ام جي بتساوي تي صح؟
صحيح. لو الجسم ثابت معناته small m and large m are equal.
صحيح.
تمام، معناته they are equal و mg is equal t. احنا we are talking about Newton's second law and we're applying Newton's second law. So now the physics part of this kind of problem is to write the two equations. How you solve it? It's mathematical problem, it's not physics problem. Yani use your mathematical experience to solve the problem depending on the numbers you are given. But a simple solution, just here you have minus t and here you have plus t. If you add the two equations, t will disappear and then you end up with a new equation. So let's add them. So it will be mg minus small mg is equal m plus m. And here g, m minus m, and the other side a is equal m plus m. And then you can solve it depending on the problem, what is missing. Is it small m missing or capital M missing or acceleration missing, depending on the problem. Any question? Because those are the physics equation. Mathematically, you are responsible to solve them. Physics-wise, I'm explaining the physics for it. طيب, let's go now for a typical problem. Also, you find it in all physics books, this situation, that you have an object on an inclined plane moving, and an object on the other side, and they are moving with acceleration. They are moving with acceleration. If they are moving without acceleration, then it's a different problem. But now, both of them are moving with acceleration. So let's analyze this kind of problem. So we have small m, and then we have capital M. So let's assume that it is moving in this direction. And all our problems up to now, there is no friction. Friction will complicate the problem a lot. طيب, let's analyze the force. We have here mg sine theta. We have tension, and we have tension, and we have small mg. Here is theta. And if you don't understand how it is mg sine theta, return back to the previous video when we explain it in details. طيب, so let's look at the equations we have. So the first equation, the object is moving in this direction, so the small m will move upward. So that means the first equation will be t minus small mg is equal small ma. That's the first equation. The second equation for the object, the big object, and the equation is, because it's moving this way, that means mg sine theta minus tension is equal wait a second, this is capital M, and this is capital M, is equal capital M A. And this is the second physics equation we can write. And we have a third one talking about the normal force. Well, we have this component mg sine theta, and we have this mg cosine theta. So we have the normal force, which is equal mg cosine theta. So the third equation, the normal force is equal mg cosine theta. So those are the three equations we can write when we have this situation. كابيتال، صح. مين الصاحي معاي هذا؟ ما شاء الله. داود والله انك بطل. هاي كابيتال ام. Well, how do I determine T is equal mg? Because I'm talking about the small mass. What are the forcing? It's just applying Newton's second law. What are the forces acting on the small m? Well, we have tension upward and we have mg downward. So the equation is T minus mg is equal ma. تفضل يا عادل.
So, Doctor, basically the movement is always towards the greater mass direction, right?
Of course.
Okay.
Of course. It's very simple when we don't have friction. Even if you don't know the direction and you write the equations and suddenly you discover that A is negative, then that means you just flip the directions with no friction. It's very simple.
Okay.
Also here, in these equations, if you find acceleration is negative, that means you just flipped the equations. No friction, so it's simple, very simple. When we talk about friction, it's a different story.
Okay.
But here, we don't have friction, so you can write these three simple equations, and depending on the situation, you can solve it.
Okay.
How you can solve it? Well, it's just applying your mathematical experience.
Yeah, I know that.
Now, if you go and see the book, he will just continue for pages to analyze those equations and finally reach A is equal some complicated value. But you don't need to go into that route, يعني. You just have to understand those three key equations, and depending on your problem, you use them.
Okay. Actually, this chapter in the book is too big, too wordy.
Yes, it is. It was given only 2 lectures, but that's not enough. يعني, if we want to cover the friction only, it will take 1 lecture, 1 full lecture.
That's too much.
Yeah. The third equation, one of your friends, Asim, asked, repeat the third equation. Well, it's the normal force, which is mz cosine theta. We analyzed this in a previous video. We took our time. We said that this is mg, and we analyze, we assume y-axis and x-axis. So return back to the video because our time is very, very limited. We cannot just repeat everything each time. الحين يعني مثلا in the book we can use these two equations. For example, يعني he spent a lot of time IFN is equal mg capital M cosine theta, and we have this equation mg sine theta is equal ma plus tension. So if you divide both of them, you end up tan theta is equal ma plus tension over the normal force. But you don't need to go through that avenue يعني. What you need to know is how to write those three physics equations. That's the most important. Now how you calculate them, how you solve them, depending on your mathematical experience and not on your physics experience. Your physics experience will allow you to write those three equations. Can you go right? You mean like this? So this is the example, because the book, he will go on and go on and go on and finally analyze A with a bunch of symbols. You don't need to go that avenue. What you need to understand is those three equations. And the mark in the question will be heavily if you can write those equations or not. If you can and then you do a mathematical mistake, well, I will deduct a small amount of a mark. However, if you do any mistake on those equations, the penalty will be very large, because the physics is here, not how to solve the equations. The physics is how to write those three equations. And again, there is no friction, so if you do a mistake in the sign of the equations, we assume that it is going downward, but it is, after we solve it, we find acceleration is negative. That means it is going upward with no friction, no problem. If we have friction, no, we have to repeat the equations again. But we didn't reach the friction yet. Doctor of the masses were the opposite. We will just flip. Yeah, suppose that your friend is asking, suppose that the motion is going upward. Well, in that situation, it will be, from this side, it will move downward, so it will be mg minus t is equal ma. Not t minus mg. It will be mg minus t is equal ma. And if it is moving up here, we will have tension minus mg sine theta is equal ma. Normal force will stay the same. The third equation is the normal force. It's not friction yet. The third equation is the normal force, just the normal force. We are going to use the normal force to calculate friction, but it will come, not now. Now we cannot use it to calculate friction because we didn't introduce friction yet, but still we can use it as a beneficial equation. Like here,
Doctor,
for example.
I mean the equations that you put here, I don't understand why did you put the normal force in it?
because
equations on the right.
it will help us to solve the equations depending on the problem. Depending.
Okay, can you just briefly just explain how did you get the equation on the right?
On the right?
Like, how did you combine them together? Yeah.
Ah, you mean this one?
Yes, yes.
Yeah, this is
How did
what
you
I'm
get
saying. This is what I'm saying. I gave an example. You know, the book will go for pages to finally calculate the acceleration. You don't need to go that avenue. I gave an example. I used equation number 2 and equation number 1 and to get a tan theta.
Doctor, there is a missing G.
There
for
is
the
missing
sign.
G. Yeah, that's correct. So here tan theta over G, tan theta over G, and G will just go to the other side. You don't need to go that avenue, but I'm giving an example
Okay,
that
what is theta again?
using those 3 equations, you can do a lot depending on your problem.
Yeah. So what is theta?
That is theta.
It's given, right? It's given already. Oh, okay.
Well, depending on the problem, I can give you everything and ask you to calculate theta.
Yes. Okay.
You see? And again, if there is no friction, it's easy. You just flip the sign. If there is friction, no, you have to repeat your equation. MG صح. والله يا داود انت يعني مفروض صراحة يعني يا ريت يحطوا فيها مشاركة، كان الحين يعني اخذت فول مارك. معناته ما في جي هون. جي So then there is no G here لأنه it went with each other. You don't need to go there. What you need to understand is how to write those 3 equations. And after that, depending on the problem, you use your equations. طيب. Now let's have another typical situation before we talk about friction. The last one, let's say. Before, no, we have to talk about friction. We cannot avoid it anymore. Anymore. Well, first of all, friction equation is some kind of coefficient, we call it friction coefficient, and it is multiplied by the normal force. It is multiplied by the normal force. Also, the force of friction is 2 types of force of friction. 2 types. We have static friction coefficient, and we have kinetic coefficient of friction. So that means we have 2 forces. If the object is not moving, the force of friction, static, is equal coefficient of friction static multiplied by the normal force. And we have force of friction kinetic is equal coefficient of friction kinetic multiplied by the normal force. Suppose that we have an object on a rough surface, and you apply a force from the left. Then right away, the force of friction will be to the right. طيب, suppose that I apply a force right to left. Then where is the force of friction? It will be opposite direction. So always the force of friction is opposing the motion. That's one. Two, أهلا وسهلا بذكر الله. Situation two, the force is acting on an object, so you have static force of friction. The more force you apply, the more friction you will get. And the reason for that, summation of force is equal MA. And because the object is not moving, معناته is equal to 0. So that means whatever force you apply must be equal to the force of friction. And this is static. So if you increase the force, you will increase the friction. Increase the force, increase the friction. So we have this situation. Increase the force, increase the friction. Increase the force, increase the friction. Until you reach to force of friction maximum, or the breaking point of friction, and then friction will go down to the kinetic friction. So increase the force, the object will not move because of friction is increased. Increase again, friction will increase again. Increase again, friction will increase again until you reach friction maximum. And then after that, the object will start moving and friction is less. And that is kinetic friction. تفضل يا عادل.
So doctor, basically the friction maximum value is, like we can say that it is the minimum value in order to move the object.
It is the minimum force required to move the object. That's correct.
Okay.
And it is the maximum friction force. The maximum friction static force. That's maximum. And you can see
So
here,
at that point,
it's a static and it's maximum.
yeah. So at that point, is the object like in equilibrium, or like is it
Still
like moving? Or
still in equilibrium.
floating?
Yeah, still in equilibrium. And we call it the object is about to move. يعني a tiny bit of force, it will make the object move.
Okay.
About
I
to
got it.
move. We call it about to move.
Oh, all right.
طيب. So that is about friction. So in this area, it's kinetic friction, as you can see. Kinetic friction. And in this area, it's static friction. And this is Fn, the normal force. And what is the normal force in our situation? Well, in this situation, we have mg, and this is the normal force. So the normal force is equal mg in this situation. طيب. Now let's apply this. We have friction, we have our object, and the force is applied with an angle. So this is our force now. This is theta. So let's write the equations. Let's write the equations. So here it's capital Mg. Here is Fn, the normal force. For this applied force, we have Fx and we have Fy. F of x is equal F cosine theta, and F of y is equal F sine theta. So let's write our equations in the x-axis. We have F cosine theta minus the force of friction is equal, net force is equal MA. That's equation 1, and this is kinetic force. How did I know it's kinetic force? Because we have acceleration. That means the object is moving. That's the first equation. The second equation, it's the normal force. And it is equal mg minus F sine theta. That is equation 2. Why minus? Well, it's Newton's second law, so net force. That means Fn, so let me write it here, Fn plus F of y is equal mg, because there is no motion in the y-axis, capital M. So that means normal force is equal mg minus F sine theta. And of course, the last equation, the kinetic force is equal mu k multiplied by F of n, اللي هي mu k multiplied by mg minus F sine theta. If there is no acceleration, it's F static. The object is not moving. Yes. Or the object is moving. Wait a second, Dawood. Either it's no motion or the object is moving with a constant speed or constant velocity. That's correct. طيب, we studied this equation. How about the force is pointing down? So let's talk about the second equation or the second situation. Now the force is pointing down. That is our F. So let's write our equations. F cosine theta minus the force of friction is equal MA. It will not change. It's the same. Now, what will change? Well, the normal force now will change. Normal force is mg plus F sine theta. Why? Because now you have a component pointing down. So the normal force is equal mg plus Fc sine theta. مش Fc, F sine theta. The third equation is the same. Mu k multiplied by a normal force. But now mk is equal mg plus F sine theta. So again, applying the same force on the same object, if it is pointing down, it will give you different result than if it is pointing up. Any question? Clear. طيب الحين we are going to the two equations that we just solved. Now we end up with explaining the last situation in the slides, which is this situation. This situation that you have a pulley, two objects moving with acceleration. Two objects moving with acceleration. So let's try to analyze it now. So we have an object. And we have friction now. And that force is with an angle. And this is theta. And here is the point. The book approach for friction is very simple. The book did not discuss friction in general. The book approach for friction is that he will tell you the direction of motion. And the examples in the book are just for a moving object with acceleration. The book is not talking about when you have friction and the objects are moving with zero acceleration, so they can be moving or they can be stationary. So it's a very simplified version of the friction. So I will stick, because of time, to the picture of the book or the way he is explaining the friction with the book. And I will attach in your blackboard a very clear lecture for one of the professors explaining the situation of friction. If you need to have more understanding, watch the lecture carefully. But because of time restrictions, I will not go through that avenue. لأنه it's very time consuming. It will need a whole one lecture just to explain it. So we stick to the book approach that he will tell you in the problem, he will tell you the motion that the objects are moving with an acceleration, and he will give you the motion of direction. It will cut a lot when you solve those kind of problems. It will add, for sure, it will add a lot. يعني the professor took a one full lecture just to explain friction on the problems. So if you like to have more information about friction, then I will attach the lecture to the chapter so you can see it. So let's stick to the book. So the book, when you have friction, he will give you the direction of acceleration. So in this example, already he gave us the direction of acceleration. Well, it's better that you know it. It's better that you know it. It will just make things clearer for you, but I am very restricted in time. So I will explain the point of view of the book, but if you need more extra, then it's better for you. So in the book, he already told us that it is moving with acceleration and it is in this direction. So that means also we have acceleration on that direction, and based on that we write our equations. So for the small m, we have t minus mg is equal ma. That's easy. So that's our first equation. Now for the big object, we know that it's moving in this direction. So that means f cosine theta minus tension minus friction, and friction is kinetic, is equal 0. Is equal ma. Sorry. هلا داوود ولا مين بضل يصلحني؟ is equal ma. هلا لاحظوا عشان بس اعطيكم to give you a glimpse that if the object is moving right to left, then it will be tension minus cosine f cosine theta minus friction. And if you don't know which direction the object is moving, then you have to solve it in assuming both directions. But in the book, the example he gave, it's moving in one direction, and you know from the beginning where it's moving. So this is my second equation. M is equal A. We cannot have M is equal A. M is kilogram, or A is meter per second square. What do you mean M is equal A? The acceleration of the small m is the same as the acceleration of the capital M. It has to be. And the tension is the same. هلا in the future, when we talk about rotational motion, then it's a different story. Because if we consider the pulley has a mass, then it's a different situation. But now we assume the pulley is massless and the rope is massless and there is no friction in the pulley, etc., etc. So the tension is the same, and the acceleration is the same. طيب, let's write the third equation. Third equation is the normal force is equal. We just did it here. Remember? The normal force in this situation is equal mg minus f sine theta. That's our third equation. And of course, F friction static is equal mu kinetic multiplied by mg minus F sine theta. Capital M. يمان. شكرا يا يمان. So the normal force, let me just enlarge it. We just did it upstairs. So this is F cosine theta. And this is F sine theta. And this is F of n. And this is mg. So the normal force plus F sine theta is equal mg. يعني normal force is equal mg minus F sine theta. Again, the marks of physics, if you can write those equations correct or not. Once you write those three equations, it depends on your mathematical skill to use the data and solve the problem. But the whole mark or most of the mark, most of the beef, can you write those equations correctly or not? If you have a sign mistake, the equation is wrong. Well, that's the force of friction. Kinetic. It's mu k multiplied by mg minus F sine theta. And by that, basically, we cover most of the popular cases when we deal with Newton's second law. You can have a different situation, but those are the most popular. If M was between walls with friction, so then the normal force. Well, if you have a problem like a book against the wall, for example, first you need to find the normal force, and after you find the normal force, you go from there to write your equations. Yani the normal force is not necessary that it is on a table. It could be pushed on a wall, like I saw some problems that you have a book pushed against the wall, and he asks you to solve what kind of problem, but then first you need to calculate the normal force. And from the normal force, no matter where is the object, on a wall or you name it, from the normal force you calculate the force of friction. And the force friction has to be opposing the motion. And then you write your equations. So what we did here is a very simplistic problem of solving motion with friction. Very simplistic. If you need more, I will attach the lecture and it will give you a much more deeper understanding. Any question? طيب, let me stop the recording.